Hello and welcome to episode 2 of LogiCast, the podcast brought to you by LogiCarta. I'm Karl Robinson and I'm here with my colleague Jon.
Hi, I'm Jon again, and I'm in my shed. Hi.
I'm also in LogiCarta's global shed quarters here on the Sussex coast in the UK. So, the LogiCast podcast, episode 2. Every week we take a deep dive into last week's AWS news. As you may or may not know, LogiCarta produces a weekly AWS News Roundup email newsletter. I introduce that via video on all the various social channels, and then Jon and I pick a few of our favourite articles and take a bit of a deep dive into the news from last week. So this week, the first article we've picked on is actually an AWS blog post written by Kurt Tomitek, a senior solutions architect at AWS. And it's called Simplifying Serverless Permissions with AWS SAM Connectors. SAM, of course, standing for Serverless Application Model. And as is always the case, that's about all I know. I've managed the TLA. I know what it stands for. So I'm going to have to hand over to Jon to really explain what it is. But of course, serverless, very fashionable at the moment, isn't it, Jon? We've certainly been talking to some of our customers this week about taking them from a serverless to a serverless world. So tell me about simplifying serverless permissions with AWS SAM connectors.
Okay, this is fun. And fun in the real sense, because I spent the best part of the last 2 years before coming and doing this spectacularly fun podcast, building out some infrastructure in serverless using SAM, because all of the other ways of deploying Lambdas are horrible. There's not a good one. They're all horrible. SAM is kind of the least horrible. The problem with SAM is it's an if you're not familiar, SAM is an abstraction on top of CloudFormation. It's a transform layer, and it adds a few unique resources that take the nasty bits out of packaging and deploying Lambdas away, so you don't have to worry about zipping it and uploading it and referencing it in there. You just tell SAM where it is, it grabs it, does all of that, does an MD5 sum on it so that it knows when it needs to re-upload and all that jazz. It's great, it's brilliant, love it. The problem comes in permissions, because if it's not DNS, it's permissions. The problem comes in permissions because it's all done in IAM. And defining IAM roles and policies in CloudFormation is awful. It's horrible, because you're doing it just in JSON if you're writing a CloudFormation in JSON, or you're kind of doing a JSONified YAML if you're doing it in YAML, and that's horrific as well. And then on top of that, you need to know the ins and outs of every single thing that your function needs to run, to have access to, or it'll just sort of bomb out and give you an unhelpful error message. I don't have access to this. Or in some cases, the error message for not having access is, I couldn't find this. You can get 404s from some resources for not having permissions, which is great from a security perspective because it means you can't enumerate it. But as a developer, that's really irritating. What the SAM connectors are doing, and honestly, I wish these had come out years ago. What the SAM connectors are doing is it's just another layer of obfuscation on top of native CloudFormation. So a serverless connector, it's saying, instead of having to write an IAM policy and a role and attach the role to the Lambda and making sure that it kind of all hangs together, you write this connector and say, I need write permission on this table, please. I need read permission on that bucket, please. You don't have to know the ins and outs of how IAM works. You don't have to need about roles, groups, policies, and all that jazz. You don't have to know about the specific actions. You just need, the CRUD ops, if you like. I need read, I need write, I need delete, whatever. You don't need to know that in order to do that in S3, you need get object ACLs, read, list, all those sorts of things. You just say, I need read access, please. So yeah, that's what that does. That makes IAM in SAM templates not suck.
So what are the alternatives then? If it's better than the alternatives, what are the alternatives that do suck?
Well, the alternatives, as I say, this is an obfuscation on top of native CloudFormation. So the alternatives are you do it in native CloudFormation, or you do it in Terraform, which sucks, or you do it in, to be clear, Terraform itself doesn't suck. Nothing does IAM very well. or you go and do it in the console, which you just don't know, or you do it on the command line, which sucks.
Got it.
It just all sucks. This just sucked less.
And has that changed at all with the recent changes to IAM? Because there have been some changes to the whole naming of IAM and the structure of IAM. Is it any different now?
So that didn't really
is that
affect
just a product marketing exercise.
Yeah, option 2. What they did was they being AWS, they renamed AWS SSO to IAM Identity Center, which SSO was an abstraction on top of IAM that just kind of let you do things cross-organization a lot easier, but it built on top of IAM, so they just kind of called it IAM ID Center instead. But no, that's completely unrelated to this.
Yeah. Well, there you go. Shows what I know. But no, thank you for that detailed explanation, John. So actually the first 2 or 3 articles that we're going to pick on this week, they're all AWS blog posts. The next one that we chose was chaos engineering. And for some reason, whenever I think of chaos engineering, I just picture monkeys monkeying around. I'm sure it's nothing to do with monkeys whatsoever. I also think of Netflix, because I think they the ones who pioneered the technique and perhaps even coined the term. Yeah, I've got a very kind of rough, high-level idea about chaos engineering, but tell us more.
In your ineffable way, Carl, you have come a roundabout way of quoting it. Chaos monkeys were created by Netflix. It's a thing.
That's why I think about monkeys. I knew there was a reason. It's not just my random brain coming up with these things.
So, yeah, right. You're not wrong. Netflix were the first people to start doing this. The short version of what chaos engineering is, and it says this in the article, it's running experiments in your infrastructure. It's got a rep for doing it in prod, but you don't have to, which is why it's kind of fallen out of favour of late, because, people don't want to be running experiments in production. They just want to be running production. So you don't have to do it there. But it's running experiments, getting things to slow down randomly, to die randomly, servers turning off, that sort of thing, queues throttling randomly. That's the rough sort of idea. The 3 chaos animals that I think are popular that Netflix came out with. Netflix did the chaos monkey, which just randomly throws faults at things. And then there's the chaos gorilla, which randomly smashes things and just destroys servers and stuff. And then I think there's the chaos snail that causes random slowdowns in places. So the whole zoo coming out to play.
I like the monkey and gorilla analogy because I see them as quite chaotic creatures, but I can't say that I've ever considered a snail to be particularly chaotic. Although their trails can be quite random at times. They don't tend to like to go from A to B in a straight line, it would appear. So what else is this article telling us about chaos engineering?
Well, yeah, so it talks about the shared responsibility model, because Amazon can't put a blog post out without talking about the shared responsibility model. It's sort of like bad juju, I think, for them. You've got to talk about, if you talk about doing things that aren't perfect, talk about the fact that it's not our fault if it breaks. Cool. So it talks about the shared responsibility model. You usually see that in security land, but in this case it's resilience, which is, they're responsible for resilience of the cloud, like their data centers aren't catching fire all the time, and that they've got lots of them available and that sort of thing. And the customer is responsible for resilience in the cloud, making sure that you're architecting subject to best practice, going multi-AZ and backing things up and so on and so on. So they've spoken about that because, like I say, it's like Beetlejuice. You say AWS 3 times and they talk about the shared responsibility model. And then they talk about resilience in the cloud. Go on.
No, you carry on, John. You carry on.
Okay. And then they talk about resilience in the cloud a bit more once they put their spectacularly dull diagram in. Architecting your workloads, talking about the well-architected frameworks reliability pillar, because obviously everybody knows what that is. Talking about regulated environments, doing DR and all that boring stuff. And then they start talking about the real world, which is scary from a cloud provider. They talk about Hurricane Sandy taking down critical infrastructure in the northeast US back in 2012. And continuity plans not taking account of people living not where they worked.
Yeah.
Which
I
is
missed
mad.
a flight to the US in Hurricane Sandy, actually. I was sitting in a Heathrow departure lounge waiting for a flight to New York, which got delayed and eventually cancelled. Of course, the great thing when you're sitting in an airport lounge and you're getting delays is you can just continue to enjoy the hospitality. Thankfully, I didn't fly straight into the eye of the storm, but managed to escape that one,
737.
I think. Yeah. So in terms of chaos engineering in AWS, then, are they doing this themselves on the part of the cloud that they're responsible for, or are they saying that this is your responsibility as a customer to release your own monkeys, gorillas, and snails into the cloud?
Whether they're doing chaos engineering in their side or not, they don't talk about it here. I would imagine that they are, but that's not something that they're going to expose to people in a blog post. They then do go on to talk about fault injection simulator, because whoever named this is boring. AWS, they could have called it the Amazon Gorilla. They could have called it the Amazon Hippo, but no, fault injection simulator. Okay. So FIS, they then talk about what it is and what it does. Injects faults in a simulated manner. Yeah.
Okay. It doesn't simulate the injection of faults. I'm not sure what the difference is really, but there we go.
What it's doing is it's doing things like terminating resources, forcing things to fail over from one AZ to another, throttling, dropping packets, that kind of stuff. You know, what you'd get from your chaos animals, but in Amazon land. And then they sort of set up, they show like a diagram of how you can do it and how you can set up CloudWatch alarms as guardrails to terminate experiments if things start going outside the bounds of kind of where you wanted them to be and that kind of thing. And what they're saying is that they have a whole toolkit with integrates with external tools such as Chaos Toolkit and Chaos Mesh, which I've never heard of, so that you can inject sort of faults that they can supply and faults that third parties can supply. But what they're really saying is that here's, what chaos engineering is, here's how we can help you do it in your environment. Got it.
So obviously Netflix is a huge organization with global infrastructure, and going to need a lot of monkeys and gorillas to find the faults in that. Is this relevant in smaller environments? How big do you need to be to take advantage of chaos engineering?
I wouldn't say you needed to be big or small to take advantage of it. I would, however, say that if you're quite small, scrappy kind of startup land, you're going to have far too many bugs to worrying about injecting fake faults to start with. You can have enough real ones.
I often consider myself as a bit of a chaos engineer. I'm very good at breaking things, so maybe this is a path I should follow in my career. Break bigger things. Yeah.
So no, you don't have to be a particularly big or small scale, but I would suggest that if you're small, scrappy startup still, you have bigger things to be worrying about, like making sure that your features work at all and that you can deliver for your customers before worrying about, weird edge cases that you don't know about.
Just on the Mechanical Turk, was that an Amazon thing, or was that somebody else that invented?
It was an Amazon thing. It was a way of getting NAF jobs run by people in low cost areas. So you transcribe
Not
these 35,000
Turkey.
posts for me, that kind of thing. No, Mechanical Turk, TURK.
Yeah,
but not
that's
specifically
an abbreviation
Turkey.
for someone from Turkey, is it not?
Yes, but not in this context. I think it's some sort of automaton, like old Victorian language. I think. But yeah, that was an Amazon thing. But I wouldn't recommend signing up for
completely irrelevant here, but no. Completely. I wonder if it's still a thing. We need to check that out. Anyway, let's move on from chaos engineering to our third article and AWS blog post. This one is about backup and restore strategies for large databases on Amazon RDS for SQL Server by Yogi Bharat and Vikas Babugali. I apologize, guys, if I've pronounced your names incorrectly. But John, tell us more about backup and restore strategies for large databases on Amazon RDS for SQL Server.
Before I do, I have to apologise to anyone listening for picking this article, because it's very dry and very hardcore engineering, so I'm sorry.
You did choose it, though, John, I have to say.
I did. For my sins, yes, I did. I spent 3 years working for a large, well-known bank that used SQL Server to run an ETL system. So I'm familiar with backing up and restoring SQL Server and how horrible it is. So that's why I've picked it.
Go for it. Did you? I thought you picked it because you were very dry and a hardcore engineer.
Hang on, let me get a little bit less dry.
Yeah.
With my LogiCast branded water bottle. So
maybe we should start giving those away.
Backing up and maybe. Right. Shall I talk about it? Right, there we go. Backing up and restoring SQL Server. So there is a native approach. There is a native option because SQL Server doesn't just live in the cloud. It was a product before the cloud was a thing. RDS supports the native approach for SQL Server backups, right? And you run, what have they done? They've put, in the RDS backup database, they've put a stored procedure in one of the system databases when you spin up RDS, right? And it's got stored procs for backing up RDS databases that support backing up directly to S3. So in on-prem land, or if you've rolled it yourself and running it on an EC2, but it's not AWS aware, then you spit your backups out to disk. Yeah, they just come out in files, up to 10, I think, because it can chunk them. It spits them out to disk, and then you can load them back in again using, again, built-in stored proc, and it reads them from kind of where you tell it to. AWS have AWSified this a bit by adding support for going directly to S3 with your backups, which is great, because if you're backing up terabytes and terabytes and terabytes of data, the only place you can reliably put that these days is S3, because it's functionally unlimited. It's also put built-in support for encrypting these with KMS, which again is a great thing because you want to be able to encrypt your database backups, because if you've got secure access to your database and then you've just left your backups on a USB key and lost them on the bus, fat lot of good it's done you. So it's gone straight to S3 and it's been encrypted. Happy days, lovely. And then, you know, the usuals on whether you're overwriting or not, and if it's a differential backup or a full backup, and so on and so on. So it supports that, like I say, with a few extra bits and pieces. The backups take a while, just because of the size of the databases that they're working with here. And they've got timings and kind of how much and how many errors that they saw and retries and that sort of thing. And then they talk about restoring from said files, and you can restore directly from S3, you know, on these files, which is great. Because you don't have to muck around. If you've ever had the misfortune of having to do this pre-AWS or pre-really quick data transfers, moving terabytes and terabytes of files around, it takes you all day. It's horrible. Or you end up needing just these massive SAN drives in places that you can get to them. And doing it direct to and from S3, happy days. Just brilliant. It's fantastic. So you don't have to worry about your data storage. But what it is saying is that the restores are taking, you know, the backups are taking hours and the restores are taking hours. I think a 5 terabyte restore here took, 470 minutes, which is 8 hours or so. It's a very long time. And then they talk about the snapshot approach. Now, this is not unique to SQL Server in RDS, right? All of RDS supports snapshots. What snapshots do, automated backups and manual snapshots, they do the same thing. They functionally take an image of the disks and the server and stuff at a particular point in time, stores it off in, it uses S3 under the covers, but it's not putting it in a bucket that you have access to, but it is in S3 under the covers, and then just sequesters that away and hangs on to it. What they are saying here is they're a bit less detailed in what they're doing, because it's AWS RDS functionality rather than SQL functionality. But what they're saying is, whilst the backups are taking about the same length of time, a 10 terabyte database took 11 hours to back up, the restore only took 23 minutes rather than 5 hours, 8 hours. So it is much faster to restore from a snapshot if you have that as an option. And then after the initial manual snapshot, the next one only took 5 minutes to take, with a restore of about 20 minutes again. And the reason for this is they don't really advertise this, but what I've noticed, because they talk about it in when paying for storage for backups, but that's the only time they talk about it, is in AWS, a snapshot, every single snapshot can be treated as a full backup, but they're not. They're secret differential backups, which is why the first one took 11 hours and the next one took 5 minutes, because it actually only took a delta. But then you can restore the second one as if it was a full backup, which is really insanely cool, and they don't talk about it enough outside of the pricing, because in the pricing, when you pay for storing your backups, you pay for the first full one and then the diffs from there. So if you've got 3 backups, you're paying for probably 1.25's worth of storage, something like that, depending on how much data you're changing. But yeah, they should talk about that more. And then
they should hire you, John, because you talk about it a lot.
In this 5 minutes, sure. What would you do
I've heard you
me?
talking about it before. It's your chosen specialised subject. I think if you went on to Mastermind, I think you probably would talk about AWS differential snapshots.
It's either that or children's TV shows.
From which era?
From right now.
Oh, of course. Yeah, of course. Yeah. You're still in that zone. I remember that zone.
Yeah.
I'm in the chauffeuring zone. That's all I have to do for my kids nowadays, is just drive them places, because they want to go to far-flung corners of the country and they're not quite old enough to get themselves there. So you've got all that to look forward to, John.
Oh, my kids are so young.
Considering that was a dry... Considering you thought that was a dry and hardcore engineering subject, it was great to hear you enthusing about it so much.
Speaking of chauffeuring, do we want to talk about the cloud cars next?
No.
Nice little segue.
We want to talk about the environment next.
Well, do you want to talk about cars before the environment?
Cars. Well, John, now you're just changing the running order of things, and you know that that's just going to go horribly wrong. When we talk about cars, if you want to talk about cars, I can be flexible. I'm quite happy to be flexible and talk about cars. So the reason we want to talk about cars is because you may have seen an announcement from AWS yesterday that they have partnered with BMW on a cloud-based vehicle data platform to power a new generation of connected cars. So we like cars and we like tech, so we thought, let's pick on that article and talk a little bit about connected cars. I've had some experience with connected cars, and to be honest, in the early days, it was all a bit naff. It didn't really do very much. You had an app on your phone, and you could see how much fuel you had in your car. Well, that's really useful, because when you get in the car, you've got a fuel gauge there, so it's kind of pointless. But I think things have moved on quite a bit since those early days, particularly with the likes of Tesla, etc. Obviously, this article is not about Tesla. This article is about BMW. But the way we are going in terms of autonomous cars, driverless cars, and so on and so forth, the whole connected car thing is becoming, rather mainstream. So, John, there's a nice segue for you to talk about cars of the connected variety.
Okay, so the article that I'm looking at is from SiliconANGLE, which I don't think was on the newsletter, but the newsletter had the official announcement, I think, which was quite light on detail. It was very corporate. But to be fair, this announcement is quite light on detail, presumably because it's tied up in lots of NDAs and business secrets and all the rest of it. The short version, and I can't really do a short version because the article's quite short, is AWS and BMW software teams have worked together to, I think, triple the amount of data that they can pull out of modern cars. Because, like you say, it would have just been, here's a fuel gauge. Wonderful. And now it'll be doing things like tyre pressures and directions and tyre wear and basically anything that you can get on a Formula One car remotely. Because that's probably where the driver from this is coming from as well, because motorsport drives innovation in commercial vehicles, in retail vehicles and non-motorsport, and then Amazon has sort of gone, oh, we can do software, and they've kind of hooked in on top. But what they're saying here is that AWS have worked with BMW to pull out a whole bunch of cool data, but they've not really told you what it is, presumably because it's proprietary. Slap it in AWS in a secure manner, whatever that actually means, and then they're planning to make it available to other vehicle makers soon as part of its AWS for Automotive offering, which, looking at their page, is a sales page. But they talk about Lyft and BMW Group and Volkswagen Group and Rivian and digital engagement for your customers and product engineering and helping your supply chain and your manufacturing and all of that, because as we all know, everything is software driven, even if it's not. It is.
Of course, yeah. And I think this is less about the kind of end user aspect of connected cars and perhaps more about the kind of large fleet management aspect of connected cars, because even the likes of BMW, when they're selling a car to an individual, they're still effectively managing that as part of a fleet of vehicles that they have on the road. So they want to know, things like preventive maintenance notifications, etc., so that if there's a problem with the vehicle, they can get in touch with the driver, get that brought back to base to have it repaired before it becomes a more serious problem and that kind of thing. So all of that stuff is really pretty cool. A slight tangent, because I do often go off on tangents. I did have a connected bike at one point. It got stolen in London, but my Ducati Multistrada had a lovely app that you could connect to the bike, and it would give you such wonderful information as lean angle. So that was always a challenge, to go out and see how far you could lean the bike over, so you could brag to your friends and show them on the phone the lean angle that you'd achieved on that day. Not particularly relevant to this article, but fun nonetheless. So do you want to say anything else about connected cars, John, or should we go back to the to the previous item on the agenda?
Would you brag about your lean angle if you'd fallen off? My lean angle? I was at 90 degrees, mate.
No, you don't show that. You don't show that one. No, it's only the 89 degree one that you survived. That's the one you got to show. So.
You're at 89 degrees because you're scraping along on your leg.
Yeah, well, your foot hits the floor on a bike like that before anything else. So, but actually, the super bikes and the MotoGP bikes lean beyond 90 degrees because they're hanging right off the bike. But that's probably a different podcast to talk about motorbikes in that level of detail. So, the other one that we skipped over because of your neat or not so neat segue into cars was this article about how cloud native computing is good for the environment. So I guess we ought to start, for the people who don't understand what cloud native computing is, just to talk a little bit about what that phrase actually means.
Oh, you're the salesman. You sell it. No? Okay. Cloud native computing.
Yeah.
Okay. So, do you want me to go? Do you want me to do it? I'll do it. Okay.
If you're comfortable doing it, John, go for it.
Always be uncomfortable. So, cloud native computing. Right. Computing in its kind of, I'm not talking Charles Babbage turning handles, is running stuff on machines, on computers, on servers, on integrated processors, on whatever. Previously, you had to, if you wanted to run a website, you needed a server to do that. That's not considered cloud native because you could do it in not the cloud. Yeah, cloud native is things like serverless, containers, kind of lambdas, which is more serverless, but particular implementation. Function as a service, database as a service, doing things that you previously couldn't do, but doing them in the cloud. So that's what cloud native means. It's things that have been designed to work with the cloud as opposed to work on the cloud, if you like. Because servers run on the cloud, serverless is working with the cloud. So that's cloud native computing. Did I sell it?
You did. I'm sold. And also I'm a bit of a hippie, so I want to know why it's good for the environment.
Resource density. Really boring, but if you are doing things in such a way that you're not running, so if you want to run a web server, even in Amazon, you are massively over provisioning, probably quite a lot of the time, because your noddy little WordPress site is getting a couple of hundred people a day if you're lucky. Like I know my blog gets one person a month. It really doesn't need to be provisioned particularly highly. Massively over provisioned, and it's sitting there spinning its wheels, wasting clock cycles, wasting power and cooling, which is more power, because we're generating heat with power and then we have to cool it down by using more power, just to sit there doing nothing. Serverless, cloud native, serverless in particular, if you're not using it, it's not there. I mean, it is, but someone else can use it. Yeah, that's kind of the idea. And because you're not using that compute capacity, so someone else is using that compute capacity, you get much higher resource density. Containers are a good example of this, right? Because on the same sort of size instance that you can run, you're historically running your one Apache instance, you could run 30 of them if if you're over provisioned. You just run a lot more in a lot smaller space. So that's kind of the big thing. And then on top of that, Amazon, Google, Microsoft, the hyperscalers, so not IBM, are much better at running data centers than, I was going to say Walmart, but Walmart probably quite good at running data centers. They're much better at running efficient data centers than ye olde website hosting provider that's got 3 racks in a cupboard somewhere. Yeah, because they run it at such ridiculous scale. They've got such experience with it because they're doing it so much. They're building up decades of engineering expertise in short spaces of time because they're doing it so much. And then on top of that, if you talk about, you could get really kind of into the weeds on the physics on this. The power you generate isn't the power that you receive at the other end of the cable. You lose some of it. So if you're moving power to fewer places, you're losing less power in like heating in the wires and stuff. And then the data centers, what they tend to do, if they can, is they put them near things like wind farms and hydroelectric dams and all that kind of thing, because renewables, they don't store very well. Our grid, as particularly in the UK, but other parts of the world as well, are not set up to work with renewables, because renewables are kind of up and down a bit. You get power when it's windy or when it's sunny or when the tide's going in or out, but not when you need it. And the grids are set up to work with power kind of being at a nice constant level. So by setting up near renewables, when there's a surplus, they can just kind of hoover some of that up and run a bit more, or store it somewhere, because they're quite good at that as well. So that's kind of it in a nutshell. And the article says this about data centers in general, but a little while ago Microsoft ran a trial of putting servers, a mini data center, underwater, because you can, just in a nitrogen sealed box. They did it off the coast of the Orkneys, I think, because again they've got loads of spare wind power up there, so they just stuck it underwater there, which meant, oh look, you're running cheaper because you're right next to surplus power. You're not having to run cooling because you're underwater.
It must have been quite tricky to have a hard drive swapped out in that data center, though, if one did fail.
I mean, yes, the results of that particular experiment was that the hardware rate of failure was actually lower than in a normal data center. So whilst they couldn't just pick it up to change a drive, they failed less.
But when they did fail, you need a qualified diver to come down and well, a qualified diver who is also qualified to replace parts in servers. So yeah, it's probably quite a niche skill set.
Bit niche.
But, I'm sure it exists. I'm sure it exists. And they probably get
Well, no,
paid
they
an
were
awful lot of
sealed
money.
because they just filled them with
sounds like quite a
nitrogen.
good job, actually. So
They were completely sealed, so you had to pull them out of the ground. Because they were sealed units full of nitrogen, which is presumably why they were failing less, because oxygen is what causes failures quite a lot. Because if you crack open a spinning hard drive, it's full of nitrogen.
I guess it didn't need a fire suppression system in that particular data center.
No, it's underwater.
Yeah, exactly.
Oh, and my cat has
So,
joined us. Hello.
Yeah. So yeah, I
Nope,
guess
she's staying on the
it's
desk.
obvious
Okay.
then why cloud native computing is better for the environment. I was actually had dinner with a friend and former colleague last week who was telling me about some data centers they were in the process of decommissioning that had 10-year-old servers in them with customers who'd left 5 years ago, and the things were still powered on. So I think that's the opposite end of the scale. So there's still an awful lot to do in the data center industry in order to make it more sustainable. But I guess as more and more people start to adopt serverless technologies and cloud native technologies, then that can only be a good thing for the planet, I guess. But we're out of time now, John, I'm afraid. So I think we ought to really wrap up, especially as your cat seems to be getting rather restless. So we'll leave you to sort that out.
Needy.
And thank you to anyone listening. That brings us to the end of episode 2 of LogiCast. We'll be back next week for another deep dive into the AWS news. Until then, you've got a couple of episodes to download from your favorite podcast distribution channel. We are now live on all of the usual podcast outlets: iTunes, Amazon, Google Podcasts, etc. So do check us out, and we will speak to you again next time. Thanks for listening.